Welcome back to linear algebra. It's been a day or two because I was sick. Now, let's jump into Anki. Unfortunately, we lost our streak on Anki, which was almost the longest it's ever been, but I got sick. That sucks. I think I actually missed 2 days. Yeah, I did because I was sick. All right, what do we got? What must be true of the diagonal entries for a diagonal matrix D to be invertible? They have to be non-zero. What is an invertible matrix? What is the name for such a matrix? An invertible matrix is a square matrix in which another square matrix of the same size exists that, when multiplied together, get I. Identity matrix that size. Non-singular is another name for it. And also commutes with that, but yeah, that's implicit at this point. If I diagonal matrix D has diagonal entries d1, d2, dn, and if k is a positive integer, what is d to the power k? It's the square matrix in which the main diagonal, each of the d's is multiplied to the power, or is to the power of k. An invertible diagonal matrix D has diagonal entries d1, d2, dn. What is d to the -1, or the inverse of d? Diagonal matrix in which the successive entries are d1 to the power of -1, d2 to the negative power of -1, dn to the negative power to the power of -1. All right, good. Now, we started reading 1.8, if I recall correctly. What was that about? It's been like 2 or 3 days. 2 days. Yeah. Something about vectors. Call vectors. What else? I don't know. We're gonna have to just grab it and look. Linear transformations is what the section's about. All right. Transforming or mapping is converting one matrix into another matrix via matrix multiplication. One vector into another vector via matrix multiplication. R to the power n, this is a set of all potential set of all n tuples of real numbers. Set of all ordered n tuples of real numbers. Oh, wow. Okay, infinite. So we can convert an n tuple in that, what is it called? Comma delineated form. Yeah. Into column vector form. Standard basis vectors. Okay, these E vectors. Okay, these E vectors. These E vectors, it's basically all the entries in the E vector are 0 except for 1 is 1. E1 would be in 1 in the first entry. These are standard basis vectors, and then you can multiply them with column row expansions. No, would really be like linear combination of them can get you any vector. All right, that's rough, but I'm gonna jump back in, continue reading, and then I'll be back to recall what I learned a little bit. All right, we're definitely getting into more advanced stuff now, linear algebra. As for what we read in the textbook, I read one section. It was called Functions and Transformations. So an introduction on functions, transformations, and terms such as values, images, domains, codomains, and ranges. So a function is a rule that converts entries of one set into exactly one entry converts into exactly one entry of another from another set. Okay, I think that's generally good. So if we take a function, say b equals f of a, then from that we can say that b is an image of f under a, and f a is a value of f, but somehow that relates in there. And then the set A is the domain of f, b is the codomain of f, and then the range. A range is a subset of the codomain in which something like all the images of the elements of A are in B. Something along those lines. Function is a rule that associates elements of one set to exactly one element of another set. Associates an element. It is elements. I didn't state that right. So associates elements of one set with, so associates each element instead of elements. There you go. All right. Value or image. B is the image of f under A. I got that. F of A is the value of f at A. Okay. All right, that makes sense. Codomain set of A is the domain of f. Good. Set B is the codomain of f. Good. So range is a subset of codomain. Good. Consists of all images of elements in the domain. Okay, I think that's generally okay. And then I actually inputted 4 more Anki flashcards from 1.7. So that's pretty much it for today. Talk to you tomorrow. See you.